Okay, so the first question says evaluate the summation from r equals to 1 to infinity of tan of x upon 2 to the r and sec of x upon 2 to the r minus 1, where x is an acute angle. Okay, wow. Okay, let us see what we can do. So you have x upon 2 to the r and x upon 2 to the r minus 1. So x upon 2 to the r, wait, what? Okay, x upon 2 to the r minus 1 is actually 2 times x upon 2 to the r. So I will call this thing as theta for now. I mean, I should call this as theta r, maybe, whatever. So what I get is tan of theta r and sec of theta 2r. Okay, cool, over there. But then I can actually write it in a different way. So tan of theta r, and then this thing can be written as 1 minus, wait, yes, that's correct. So 1 plus tan squared of theta r upon 1 minus tan squared of theta r. Okay, so can we somehow make some connection? Let's see. 1 minus tan squared theta r, and then you don't have tan squared over there, so that's a problem. But okay, fine. Okay, theta r, yeah, it's almost the same things like theta 2r. So we should say 2 theta r, that will make sense. So 2 theta r, yes. Now what do we do? So tan theta r minus 1 upon tan theta r, no, that won't work like this. We need to telescope this. So let's see if we can somehow make sense into that thing. So you can already see that over here theta is always in a geometric progression, right? So you will have theta r, then you have theta 2r. I mean 2 times theta r, then you have 3 times, no wait, 4 times theta r, then 8 times theta r, and it will keep on going like that. So in that case, maybe we can apply these things like tan theta r upon 1 minus tan theta r into 1 plus tan squared of theta r upon 1 plus tan theta r, right? So why did I do this? Because you see that this thing uh, is almost like what we did in the last video, right? So yeah, almost like that. Okay, fine. So we'll have this thing tan theta. The next term is supposed to be tan of you will have 2 theta r, right? So 2 theta r, that will be 1 plus yes, so every time theta r will be replaced by 2 theta r in that case. Tan of 2 theta r, wait, it's not working because tan theta r is also changing, so we won't be able to do it like that. Fine, so we need to figure out some other way or something. Maybe we can deal with square roots. I don't know. So 1 plus, fine. What about a cubic in that case? So tan square over there. No, I don't think that would be nice too. Uh, but surely 1 plus tan square theta, that can be in fact written in a different way that is much more usable. That can be written as tan theta r and then 1 minus tan squared. I mean, like, okay, not like that exactly. 1, no, not 1, 2. 2 minus 1 minus tan of, okay, tan squared of theta r. And then thing divided by 1 minus tan squared theta r. Wait, okay, I can see that there is something which is happening. You have 2 tan theta r upon 1 minus tan squared theta r, and then you have minus something. Okay, so this cancels completely, so just have minus tan of theta r over there, right? So just have 1 into tan theta r, just tan theta r. But this thing, we know what this thing is. It's just tan of 2 times theta r minus tan of theta r. But guess what? tan of 2 theta r is just tan of theta r plus 1, right? Because we just told you that theta is defined by this expression. So when you put, right, so wait, r plus 1 or minus 1? So 2 times of theta r, oh, that's r minus 1. Okay, fine. So that is tan of theta r minus 1 minus tan theta r. So the previous term minus the current term. So if we sum this up from r equals to uh yes, 1 to infinity, right? Right. So x equals r equals to 1 to infinity uh of this thing tr, we will get the following. We will get tan of, first of all, you will put r equals to 0 over there. So tan of theta 0 minus tan of theta 1 plus tan of theta 1 minus tan of theta 2, then what, plus tan of theta 2 minus tan of theta 3, and it keeps going like that. So this will cancel till eventually you have minus tan of theta infinity. So what you're left with is tan of theta 0 minus tan of theta infinity. And now let's use the expression for theta, which is x upon 2 power r. So tan of, what is this thing, x upon 2 power 0 is just x. So tan of x minus tan of, okay, tan of x upon 2 power infinity is, yes, it's just 0. So tan of 0 is also 0. I think that's correct, right? So summation from r equals to 1 to infinity, it's supposed to be the same thing. So yes, that's how you do it. So it's just tan x minus 0, which is just tan x itself. So yeah, this was a nice question. Let's go to the next one. Okay, so the next question is evaluate the summation from r equals to 1 to n of cosec of 2 power. Wait, first of all, just resize this. Maybe you can see it as well. I forgot to do that. Okay, cool. Hopefully you can see it now. Okay, so the next thing is summation from r equals to 1 to n of cosec 2 power r theta. Uh, it has the same flavor as the previous one because you have another geometric series, but then a trigonometric ratio of that. So let's see if we can somehow write that in terms of tan theta and then do a similar thing, or maybe not. Maybe that's not what we should be doing. Yeah, let us, okay, let's see what we get. We get 1 upon, when you put, okay, fine, so like when you put 2 equals r equals to 1, you just get sine of 2 theta. So sine of 2 theta plus 1 upon sine of 4 theta plus 1 upon sine of 8 theta, and it keeps going like that. And this reminds me that there is a powerful identity which we can use over here, which is 1 upon 2 sine theta cos theta plus 1 upon 2 sine theta, actually not 2 exactly, it's supposed to be equal to 4, 4 sine theta cos theta and cos 2 theta, okay, that's nice, plus 1 upon 8 sine theta cos 2 theta all the way till cos 4 theta. Okay, that's nice. So what can we do with that now? We want this to telescope, right? Yep. So what can we do? um how do we make it telescope? That's the question. Let's see, maybe you can write cosine of 2 theta in some way. Nah, that's not nice. So what about I write 1 as sine squared plus cos squared? Maybe that will give me something. So like, yeah, that will cancel that stuff out, but not really nice. Okay, fine. um you know what, maybe it will be nice if I add more symmetry to it. So cos of 2 theta, because a lot of times adding more symmetry gives me some hint of how the solution is going to happen. So like cos of 8 theta and then cos of 8 theta over there as well. So what I have in my mind is that maybe I can write cosine of 2 theta as something like 2 cos power 2 theta minus 1, something like that. Okay. Not sure how that is going to work, but let's see. So 2 cosine of theta, that won't work. All right, so what can we do? 2 cosine square over there. Fine, it's not working. It's just not working. So maybe cos square minus sine square. Um, yeah. So cosine theta. Okay, so cot theta over there, and then minus sine will give me that thing. But no, it's not really what we wanted. What can we do with this thing? So is there anything which we are missing over there? Um, no, it doesn't look like that. So yeah, we just have to deal with it, and let's try. Okay, fine. So cosine of 2 theta, that can be written as 2 cos square theta minus 1. And then I think that is where we should be going, because you have a 2 every time, uh, which will give me the previous term, and then minus 1 will give me the next term. So maybe that will somehow simplify. Let's see what happens. So over there you have equal to, this thing can be written as 2 cosine square theta minus 1. That is supposed to be 2 gets cancelled, so you have, let's see, cosine of theta upon sine theta cosine of 2 theta, and then you have minus 1, so minus 1 upon 2 sine theta cos theta cosine of 2 theta. Well, everywhere you will have that minus 1 factor, right? Wow, that. Okay, and then 2 cosines. Okay, fine. Right, so you will have that cosine over there, cosine of 2 theta thing over there. No, it's not working, unfortunately. Yeah, it's just not working. Okay, fine. Let's see if there is some other method of doing it. So you have 1 upon sine of 2 theta, sine of 4 theta and stuff. What can we do with that? You can already see that these are in fact a geometric, in a geometric progression. So we can write it like this. So like tr is 1 upon sine of 2 power r theta. So I can write it as sine of, I mean, let's multiply by cosine instead. So cosine of 2 power r theta, and then you have cosine of 2 power r theta. Yeah, cool. So 2 power r theta, what? 2 power r plus 1. No, let's just do it. So cosine of, I think, yes, that can be done. So 2 power r plus 1 theta minus 2 power r theta. Let's see, upon which will just multiply by 2 over there. So 2, then you have sine of 2 power r plus 1 theta, right? But wait, no, that's not nice. Like 2 power r plus 1 theta, no, that won't do it. So why is it not working? It is, it's taking a lot of time. Okay, you wanna have 1, but oh, come on, how do we do it? So 2 power r plus 1 theta minus r theta. I mean 2 power r theta. Okay, cool. If I try to expand this, I will get cosine of, I don't know. This is not working. Summation from 1 to n. Right. There has to be something which we can do, because yeah, otherwise we just won't get the answer. What about we use something like cosec squared minus tan squared? Okay, maybe not. Maybe that won't help. Why not try writing it in terms of tan once again? No, just deal with what we have. So cosine of 2 power r theta, and then sine Okay, fine. um okay, so you will have r plus 1 over there, and then over there you have sine of 2 power r, something like that, right? What do I do? How do I make it happen? Okay, let's see what happens. I am not sure what's going to happen, but what would I write it as? 2 power r plus 1 in that case. What about r minus 1? Well, that can also help. Yeah, that will be better. If I write it as 2 power r minus 1, that will be much better. So cosine of 2 power r minus 1 theta, and then 2 power r minus 1 theta. Okay, cool. So now I can write it as cosine of 2 power r theta minus 2 power r plus 1 theta, I mean r minus 1 theta, upon sine of 2 power r theta. Yeah, it's almost like a conventional way of doing it, the traditional one, but I don't think there's any elegant solution to this thing now. So this thing can be done as cosine of wait, but that will give me a positive. No, wait. Oh no. Oh no. That's not nice. I don't want positive stuff. I want something to be negative at least. uh it's not working, so instead I can write sine over there. Yeah, that might help, so just write sine over there. So that will give me something which is negative. So sine of 2 power r theta cosine of 2 power r minus 1 theta divided by sine of 2 power r theta and sine of 2 power r minus 1 theta minus sine of 2 power r minus 1 theta cosine of 2 power r theta, okay, upon sine of 2 power r theta and sine of 2 power r minus 1 theta. Okay, cool. Some stuff cancels out. You can see that this cancels out, right? And then over here this cancels out, so you just have cot of 2 power r minus 1 theta minus cot of 2 power r theta. So the previous term minus the next term. Okay, cool. So now if we sum this up from r equals to 1 to n, what we will get is let's put the first term over this, like r equals to 1 will give me cot of 2 theta, cool, and then the last term will be when you put n in there, so cot of 2 power n into theta, right? So that's supposed to be our answer in that case. Fine, just move on. Okay, cool. So the next question is, first of all, just erase this thing. Okay, so the next question, where is it? It is 3 upon 1 plus 2 into 1 by 2, and then 4 upon 2 into 3 and 1 upon 2 squared. Oh yes, it is. It's okay, fine. It has the flavor of what we did in the previous videos. So 3 and then how is 4 related to that thing? Okay, 1 2 3, so that 3 is missing over there. That's what is happening. Okay, fine. So you have that half over there every time. Then what do I do? Maybe 3 squared. No, that's not nice. This can't be. Okay, okay, what? It's not working. It's just not working like that. So why not write it as 6 upon 2 squared, so that can be as 2 and 4. Okay, then this can be written as 8 upon 4 into 6 into, wait, what? No, these are actually consecutive, so that's a different story altogether. So you have 3 and 4 and then 5 on the top and stuff like that. Okay, nice. So yeah, let's see what we can do. So this thing can be written as 3 can be written as 1 plus 2, so 1 upon 1 plus 1 upon 2 into 1 by 2, which, okay, fine. And then this thing can be written as, no wait, not 2 plus 3, that's not going to work in that case. So what do we do? um you have 2 squared, and then first of all let's add symmetry to this, and let's see what we can do. So this thing can be written as 6 upon 2 into 4. This thing can be written as 8 upon 4 into 6. Wait, yes, so 8. Wait, but this time you don't have that thing, so you don't need to do all that stuff. Instead you have some kind of a ratio over there. We do want this to be telescoped, but how? um so 1 minus 2. Okay, let's see, let's just see what happens. So this okay, fine, this thing can be written as 3 into half minus 3 into half into 1 by 2 plus 4 into 1 by 2 squared into 1 by 2 minus 4 into 1 by 2 squared into 1 by, wait, what, 1 by 3. Okay, man, this is very weird. Okay, fine, plus 5 upon, wow, what do I do, 3 plus 1. Okay, that does give me the previous one, right? Fine, so that 3 gives me the next, no, that gives me the previous one, then plus 1. So that gives me 1 by 2. Similarly 5 and plus 4 plus 1, so 1 by 3 over there. Not bad, not bad. Maybe we can do that thing first. So let's try doing that first and see what we get. So this thing can be done as well. 3 can be done as 1 plus 2. So this will just give me, right, 1 plus 1 by 2. Okay, fine. No, okay, fine. So 1 upon 1 into 2 plus that 2 gives me 1 upon 1, but everything is in half. Okay, it's like into 1 by 2 plus this 4 is 3 plus 1, so 1 upon 2 into 3 plus, okay, fine, I think we are going very near to the solution. I can use that. Okay, fine, so plus 1 upon this 3 is gone in that case, so plus 1 upon 2 into 1 upon 2 squared, fine, plus 1 upon uh, okay, 1 upon 3 into 4 plus 1 upon 3 into 1 upon 2 cubed. Right, this is turning out to be an arithmetic geometric series once I make that substitution. Fine, I mean do that algebra thing. Okay, cool, up to n terms. So 1 upon so for n you will have 2 power n over there. It's like 1 upon 2 power n, but what do you have on the inside? So 1 2 3, for n you will have 1 upon n. Okay, that's fine. And then n plus 1, n plus 2, n plus 3, I mean like n plus 1, n plus 1, n plus 1 everywhere. So 1 upon n into n plus 1. Yes, this is a really nice thing. And for this series as well, what would be the last term? That would be um wait, what, you have 1 upon, right, this can be done, this can be telescoped, no big deal, right? I know this can be done. So now let's write it in a different way. This thing can be written as 1 minus 1 by 2 plus 1. Okay, I mean 1 upon 1 basically. Okay, cool, into 1 by 2. Then you have plus 1 by 2 minus 1 by 3 plus 1 by 2 into 1 by 2 squared plus 1 by plus 1 by 2, no wait, not 1 by 2, plus 1 by 3. Okay, fine, 1 by 3 minus 1 by 4 plus 1 by 3 into 1 by 2 cubed, and it will keep on going like that. So plus, okay, fine, this is a nice thing, right? This is a very nice thing. Okay, cool, plus 1 upon 4 minus 1 upon 5 plus 1 upon 4 into 1 upon 2 raised to the 6th power, I mean sorry, 2 raised to the 4th power, yes. And it will keep on going like that till you have the nth term, which can be written as 1 upon 1 upon n minus 1 upon n plus 1 plus 1 upon n into 1 upon 2 raised to n power. But then this thing can be further broken down to two different series. I mean, almost the same, but with different scaling up. Okay, fine. So 1 plus 1 is just 2 times 1. So you just have 2 times okay, so 2 times 1 by 2 is 1, so just have 1 over there. Fine. Then plus half plus half is 2 times half, but that thing times 1 by 2 square is 1 by 2 into 1 by 2. Then plus 1 by 3 plus 1 by 3 is just 2 times 1 by 3, but 2 into 1 by 2 cube is just 1 by 2 raised to the second power. Then you have 1 by 3. You have 1 by 2 raised to the third power and 1 by 4, and it will keep on going like that till you eventually have this thing. So 2 upon n into 1 upon 2 raised to the n power is supposed to be equal to 1 upon 2 raised to n minus 1 into 1 upon n. And what's the other series? That is with this thing, these negative ones. So negative half into, okay fine, this is supposed to be negative 1 by 2 into 1 by 2. Nice. And then negative 1 by 3 into 1 by 2 squared. Right, this is turning out to be like, okay fine, so 1 by 2 squared into 1 by 3, that will be better to write. 1 by 2 squared into 1 by 3, then 1 minus, okay, minus 1 upon 2 cubed into 1 upon 4, and you can see what's going on. These are supposed to be telescoping. So 1 upon 2 power 4 into 1 upon 5, and it will keep on going like that till we eventually get 1 upon n plus 1. So negative 1 upon 2 power n into n plus 1 was like, fine, 1 upon n plus 1. Cool. So these things cancel away, right? And what we are left with is 1 minus 1 upon 2 power n into n plus 1. Okay, that's nice. Which is nothing but, yeah, I think that's it. Just leave it like that. No need for simplification. So yeah, that's the answer for the last question. So I hope you enjoyed. I'll see you in the next video.